Hello again. So in the second part of the video, I'm going to go over key concepts we would need to know in order to write this code. So just to recap, we wrote code for a Ruby method to determine if a number is prime. And I'm going to go over really the bare minimum of programming concepts you need to know about in order to derive this code. So first thing is you need to know what arguments are, also known as parameters. So in our method here, it takes an argument of number. That means that when we call the method, we call it is prime, we need to pass it an argument. Now, number itself is just a placeholder. It does not matter what we call it. So let's say we want to just call this something different. We could call it something completely silly if we want. Let's just call it apples. Will this still work? Well, let's find out. Return true for the first 4 and then false for the last 5, like it should. These are all prime numbers. These are not prime numbers. So these 4 should be true. These 5 false. And that's what it did. So it doesn't matter what we call our arguments. Let's just revert it back to what it was. As long as, of course, you refer to it consistently throughout the method in the proper scope. It is, however, good practice to name your argument something that makes sense. Since this should take an argument of a number, we should call it something intuitive, right? Since humans will need to read this code and they should be able to understand it. All right, next concept. Early return values. So in Ruby, the last line with the return value in a method is the return value. So true will be the return value of this method. However, the keyword return forces an early return. And this can be very useful. There's many circumstances where we want to force an early return, both to control the flow and give the proper return value of the method, and also for efficiency. And let me show you what I mean here. If we delete this return, let's just see if this still works. And the answer is no, it got a couple of them wrong. So let's see what happened here. So these two now return true, meaning it's thinking they are prime numbers, but they are not. And here's what happened. We said false if number less than 2, but that's not the return value. It'll spit out false, but then just go to the next line. And then the next one. So we need to force an early return. There's also a question of efficiency. On line 13, we force an early return both because it's the correct thing to do. A number is not prime if it can be divided by any other integer from 2 to 1 less than the number. But we could probably get this to work, just assign it a variable and then return the variable at the end, but that's much less efficient. All right, we also have conditionals. So statements like if, that's a conditional. And there's different syntaxes for using conditionals. Here I actually have the statement before the conditional, which is a less common usage, but it makes it nice and efficient because I can write this in a single line. But I could have done this multiple lines. I could say if number.integer return false. So that would be the same as line 6. But you can tell this is more writing. So the way I wrote it is better. Comparison operators. So less than or greater than, that's a comparison operator. Double equal sign, that's a comparison operator. Comparison operators always return true or false. So let me just demonstrate that real quickly. All right, 5 less than 2, true or false? Well, that's false, of course. How about 2 equals 2? Well, that's true. Okay, we can also do it with strings. That's true. But if we change this, different string, that's false. So comparison operators are always true or false. And when you use a conditional, the code only runs if the conditional evaluates to true, or if it evaluates to truthy, and we'll talk about truthiness in a separate video. All right, other concepts. Enumerators and sets of items. So an enumerator really is just a set or a range. So when we use parentheses and a range of numbers like this, that turns it into an enumerator. And an enumerator can have methods, enumerable methods called on them, like .each. Probably a better known way of writing enumerators is to just give an array. Like here, I could do an array of 6 numbers, and that I can also call .each on it. What's the number? Okay, so that's an example right there. Enumerable methods like .each, they allow us to loop over an entire enumerable, an entire range or set. Remember, loops are when you want to do something repeatedly, and that's a really key programming concept. We want to repeatedly, for each of these integers in the set, test if this number can be divided evenly by whatever integer it's on. And the syntax for using .each, if we want to do it one line, we open a curly brace, give a parameter variable of what each element is. So if it's 2 to the number -1, for instance, the first element will be 2, the next one 3, and so on. That's what the parameter variable int represents. And here's the code that's executed. Flow control is really crucial here, and flow control is what executes in what order in a method. And that's crucial. This will not work if we put this in an inappropriate spot. Let's just cut it out. And let's just see what happens if we put this at the top of them. If we were to do something like this, now you would see it no longer works. Yep. So the order you do things in matters. Let's undo those. Okay, so those are, make sure I go over these, and then I've covered these briefly. Those are the basic concepts you need to know in order to do this method. And I went through them only briefly. We could go a lot deeper with these. But I hope that at least gives you some idea and some, what's the word I'm looking for? Some early comprehension of what these concepts are. And in the next video, I will talk about how we could improve this method. All right, thanks for listening.